The future of technology is bright with quantum. For the vast majority of human history, technology consisted of nothing more than rubbing two pieces of wood together in order to produce fire. However, modern technology encompasses everything from manipulating matter at its smallest scale to training artificial neural networks that simulate the human brain, all in order to display a meme on your phone at 3 in the morning. Welcome back to my channel, and today, we're going to peek into the future of technology with quantum. Be sure to like and subscribe to our channel for more awesome and cool videos. The device that you are using to watch this video has a processor that contains billions of tiny things on the scale of a few hundred atoms that we call transistors. Essentially, transistors are hyper-fast super switches that turn on and off billions of times every second and help process whatever it is that you want to do. From calculating 1 + 1 to listening to science files' pleasant voice speaking to you right now, transistors work as a result of this branch of physics that you've defined in your previous definition. A particle's state properties can never be predicted with absolute certainty. Instead, only a range of probabilities can be given for each possible state. Therefore, this particle is not in any given state, but rather in all states at once until it is observed, which is one of the fundamental principles of quantum mechanics. It is shown with the well-known Schrödinger's cat, and the entire field of quantum computing is built on this exact notion as opposed to the more conventional 0 or 1 bit. Quantum computing uses quantum bits, which are individual photons that are in a superposition. This means that these qubits can be both 0 and 1 at the same time, just like a coin that continuously spins and holds the possibility of being either heads or tails until it is stopped and looked at. A quantum property cannot be observed without changing or disturbing it, but why use fancy qubits when the regular ones work just fine because they come with a set of pretty neat advantages. Quantum computing uses quantum bits, which the information that is carried by qubits is characterized by a quantum feature such as the spin of an electron, which can be either up or down, or both at the same time. Qubits are particles that can represent the value 0 or 1 or a superposition of both at the same time. Because qubits are complete particles, it is not possible to copy them. However, it is conceivable to measure one qubit and produce a new one with the exact same characteristics. This does not guarantee that the state of the first qubit has not been altered throughout the measurement process. Essentially, nature is trying to keep the true state of a particle hidden from us, and we can leverage the secrecy to our advantage by employing a technique known as quantum entanglement. Encryption using quantum mechanics. The term quantum cryptography refers to a method of sending confidential information over optical fiber that utilizes qubits rather than traditional bits. When it comes to protecting the information that is being conveyed, it does so by relying on the quantum features of these qubits, which in our instance are photons with polarizations. There are 4 possible polarization states for a photon: either horizontally, vertically, diagonally to the right, or diagonally to the left. Horizontally, vertically, diagonally to the right, or diagonally to the left polarized photons may each represent a qubit with a value of 1, whereas the ones in the vertical and diagonal to the left positions would each have a value of 0. When a photon with horizontal or vertical polarization is measured with a rectilinear filter, the value of the photon will not change, and the measurement will be accurate. This is analogous to what happens when a diagonal photon is measured with a diagonal filter. If the sender wants to send a series of zeros and ones, they will polarize the photons appropriately, but they will randomly choose between using rectilinear and diagonal polarizers. When a rectilinear photon's horizontal or vertical orientation is measured with a diagonal filter, the photon's polarization will become diagonal either to the right or to the left. Sender and receiver will then share the scheme and filter they used for each photon, and any bits of information for which the scheme and filter do not match will be discarded. However, if an eavesdropper is intercepting the series of photons, such as the governments of the world trying to crack down on the creation of Skynet, they will not know which filters to use because the receiver will measure the polarization of the photons using a random filter for each photon. Both the receiver and the sender have the ability to examine the polarization of some of the qubits that were not discarded. If the values do not match, it indicates that someone has altered their message, and Skynet will activate its self-preservation article. This allocation of the keys, the protocol's name is BB84, and it is one of the quantum cryptography methods that is utilized most frequently. Einstein coined the phrase spooky action at a distance to describe the phenomena of quantum entanglement, which is a phenomenon in the field of quantum mechanics. The phenomenon known as quantum entanglement occurs when two or more particles become interconnected in such a way that the state of one particle can immediately affect the state of the other particles even if they are separated by very large distances. This is true even if the particles are located very far apart. The fact that this appears to defy the concept that physical events cannot travel faster than the speed of light is the primary factor that contributed to the eerie feeling that it evoked. Quantum entanglement enables information to be transported between locations without necessitating the movement of the physical substance that holds it. One use of quantum entanglement that does this is quantum teleportation, which is an example of quantum teleportation. This permits entirely unhackable quantum networking, which is also known as device-independent quantum key distribution. This in turn enables wireless, completely secure quantum communication. It has been decided that a lean aspect will be the one to get the Nobel Prize in Physics in the year 2022. The work that John Clauser and Anton Salinger did on experiments that confirmed the existence of quantum entanglement and their contributions to the creation of quantum technology earned them the Nobel Prize in Physics. Their work was recognized for both achievements. Recent times have seen the publication of a piece of study with the title Traversable Wormhole Dynamics on a Quantum Processor. This research analyzes the similarities that exist between quantum entanglement and wormholes to understand the connection that exists between quantum physics and gravitational physics. The researchers arrived at the conclusion that these two occurrences are quite comparable to one another, and it's even possible that they're the same thing. After creating a quantum entangled system with the help of the Google Sycamore quantum computer, the researchers analyzed the characteristics of the information that was transmitted across it. They came to the conclusion that the characteristics of the information were comparable to those of a conceptual wormhole. After putting together quantum devices in a functioning quantum network, along with some quantum cryptography and quantum entanglement, basically the entire shebang up to this point, you will have created the quantum internet, which will make both the devices and the networks more secure. It is anticipated that the quantum internet would also give a higher level of privacy to its users. This is since it will be considerably more difficult for unauthorized parties to intercept and access information that is transmitted across the network. In the year 2020, this will result in there being no more huge eagle lizard corporations that are spying on you, but it will also mean that you will never be able to escape Skynet's grasp. You may remember that there was an outbreak of a pandemic that we will not name that spread across the world, and there was an immediate demand for a vaccine. In the past, it has taken more time to find a cure for the global pandemic, which is an unacceptable amount of time. In order to speed up the process, scientists make use of the High Performance Computing Consortium, which is a group of supercomputers at major technology companies and research labs including NASA. These supercomputers supplied an enormous amount of computational power, with the HPC consortium carrying out computations at a rate that is 50 times quicker than the amount that would be achieved if every individual on Earth conducted 1 million calculations per second. Imagine having all these powerful tools at your disposal, even on a device smaller than your phone. It's like having a full rocket's worth of sensor equipment right in the palm of your hand. Imagine atoms bouncing around like billiard balls. When photons encounter these atoms, there is an exchange of momentum happening there, and the photons are scattered all around, including into your eyes. This is what makes stuff visible. However, if you take a bunch of cool sensors and combine them together, quantum technology is currently making the long shift from merely being a jargon used in every other science fiction movie to an actual underpinning for the most vital technologies used by the United States of America daily. With recent developments in artificial intelligence, it won't be long before machines that are smarter than human are put into use. In the future, it is certain that the impact of quantum mechanics will only be amplified, ranging from nanobots manipulating the very fabric of the world to the possibility of even teleportation. What are your thoughts on quantum technology? Would you be excited for its future uses? Let us know in the comments section below and subscribe to our channel for more awesome videos. See you in the next one.